All right, so we're going to do an interactive lesson today looking at transformations of quadratic functions. So I'm going to use the Desmos calculator. That's why it's opened over here on the right. I'm going to graph these three equations all on the same coordinate plane. So I've got y equals x squared, y equals x squared plus 4, and y equals x squared minus 3. So I want to take a screen clip of these three graphs all together and put that on to my notes page right over here. So create that graph and put it right here on top. I didn't take a perfect square, but that's okay. All right, so we've got our graph here. So how is equation 2, okay, in my equation, so let's, just for fun, my equation 1 is the red one. My equation 2 is the blue one. And my equation 3 is the green one. So you can see them right over here as well. All right, how does my blue graph change? How is my blue graph, my equation 2, different from equation 1? All right, how is it different? Well, it has been moved up. All right, so I'm going to come over here and I'm just going to type in, actually, purple. It moved the graph up. All right, and so then from equation 3 and equation 1, from the green and the red ones, what does that one do? Well, it moves it down. All right, so what does this k? So this last thing here, so I've gotten this written as in a generic way, y equals x squared plus k. So what happens when I add something to the end of our graph, or I subtract something? So in the blue equation I added, and in the red equation I subtracted. So I'm going to come over here. If I take my k, if k, oh, that's very small. Let's make it. If k is bigger, okay, bigger than 0 or positive, okay, then my graph moves up. All right, and then the same thing if my k is less than 0 or it's negative. Okay, if it's negative or it's subtraction, what happens? It moves down. All right, so if we have a plus something, it moves up. If we have a subtract something, it moves down. So that's what k does. All right, so let's look at our next page. All right, on our next page, we're going to keep y equals x squared, our basic one. We're going to add in y equals parentheses this time, x plus 4 all squared, and y equals x minus 3 all squared. All right, so I'm actually going to change the color of this one. Let's make this green. It'll show up a little bit better. All right, so I've got a purple, a green, and a red. So let's take a picture of that and put that into our notes here. All right, so I'll come back over to my notes and add my Desmos graph. All right, so again, this time my first equation, all right, is the purple one. Okay, that's my equation 1. Equation 2 is my green one. And then equation 3 is my red one. All right, so this time I am adding or subtracting inside the function, okay? Inside the function. So inside that parentheses, inside the square root. So what does it do? Well, the plus 4 moved our graph left. So it moved it over here. And the minus 3 moved our graph to the right. So this first one, our green one moved left, and our red one moved to the right. Right? Which means it's a little bit backwards. Okay, so it looks different than what we see. So when we come down here to talk about how does it work, all right, if H, so let's write this with letters. If H is subtracting, okay, if it's subtracting, we move to the right. And if H is adding, we move to the left. Okay, so it's backwards from actually what we see. If it's negative, we go right to the positive direction. And if it's positive, we go left to the negative direction. So it's just opposite of what we see. All right, let's look at this next set. All right, again, we're going to keep y equals x squared. Then we have y equals 5x squared. And then we have y equals 1/5 x squared. All right, so what does that do to our graphs? Well, they all stay in the same place. They don't move. They all stay right here at 0, 0. But the graphs move. They get wider or they get skinnier, depending on which one it is. So let's take a little screen clipping of that. That graph was just right. All right, so how are our graphs different? All right, so let's go back and mark them. Our first graph is the blue graph. Our second graph is, equation 2 is the green graph. And equation 3 is our purple graph. All right, so this is the purple and this is the green. So what does the green graph do in relation to, how is it different from the blue? Well, what you think is that it's getting skinnier, but the way we say that in math is that it stretches vertically. You think about putting your hands above your head and stretching them straight up. That's what we're doing when we are when we have a number in that number 5 in front of our graph. So when we look at the second one, the purple one, it's like someone's grabbing our hands and pulling them down. So we call that compressing, or sometimes we say shrinking vertically. All right, so what does A do? So A, if A is greater, if A is greater than 1, our graph stretches. Our graph stretches up. If A is less than 1, then our graph compresses down. All right, so that's what it does. It either stretches up or it compresses down. All right, so then let's look at our last one here, or our last one of before we do one, put it all together. All right, so this one, I'm going to keep x squared. I'm going to add y equals negative 3x squared and y equals negative 1/3 x squared. Oops. All right, so do you see what happens here? Our graph flips upside down. It reflects over the x-axis. That's what that's called. It is called reflecting over the x-axis. So again, all our vertices, our vertex are all at the same place. We just flip the graphs upside down. All right, so how do they change? Well, let's go back. Equation 1 is our blue graph. All right, equation 2 is our black graph. I didn't mean to keep it black. Oh well. Our equation 3 is the red graph. So what do they do? All right, so they reflect over the x-axis. All right, and this one also reflects over the x-axis. All right, so in addition to reflecting, what else does it do? All right, so the black one, okay, it reflects and it stretches, but this time it stretches down. All right, and the red one compresses as well. Okay, so it compresses. So anytime we have a number that is negative, it's going to do a flip. So I'm actually going to go back and show you something real fast. So up here we had a is greater than 1 and a is less than 1. So I really actually need to put absolute value bars around here because it's really just if our a is, if the absolute value of our a is greater than 1 and the absolute value of our a is less than 1. All right, because the negative, hang on, I have an extra absolute value bar in here. The negative does a different job. So the number part, the numeral part, tells us about stretching or compressing, and the negative part flips it upside down. So for this part, I'm going to write if a is greater than 0, so it's positive, and if a is less than 0, so it's negative, our graph is going to flip or stay the same. So there is no reflection if it's positive, and if it's negative, it will reflect over x. All right, so let's put it all together here on our last set of notes. So this part, let's get rid of all those guys. Again, we're going to start off with our y equals x squared. We're going to add also y equals 2 times x plus 4 all squared plus 1. And then y equals negative 3 times x minus 2 all squared minus 4. All right, so we've got 3 different graphs on here. And I'm actually going to click on our vertices, or the vertex for each one of these, so that you can see those points on the graph when we put it on here. Screen clip our graph. All right, so I've put those on here. So what is different? Okay, so let's talk about, first, let's just talk about the blue and the green. All right, so my blue graph is my equation 1. And my green graph is my equation 2. All right, so let's talk about that one. What does it do? Well, it shifts the whole graph. All right, so it shifts 4 to the left, 1 up, and then the 2 in front stretches the graph by 2. All right, so we can write it just like that. So it shifts the 4 to the left. It shifts 4 to the left, 1 up, and stretches. Oh, actually, I'm going to put shifts. 1 up, and then stretches the graph by 2. All right, so then our second equation, what does it do? Well, it's going to shift 2 to the right, and 4 units down. And then it's going to stretch by a factor of 3. And that negative out front will reflect the graph over the x. All right, so each of these things, so the first, each of these parts down here, we put them all together. The A talks about reflection. So whether if it's negative, it flips the graph up or flips the graph down. If it's positive, it stays like it is. It also stretches or compresses our graph. So that number can stretch or compress. If it's just a 1, it doesn't do anything. All right, the H inside moves our graph left and right, which is called horizontal translation. It's a fancy word. And then the K on the outside moves our graph up and down, and that is vertical translation. Thanks for watching.